Okay, today we're going to talk about how to go from a prototype conceptual idea to getting a working schematic for that circuit in OrCAD. So part of what this project involves is designing a circuit schematic in OrCAD. And unless you have some idea in your head, probably the best place to start is with a whiteboard or on a piece of paper and sketch out the circuit and think about the logic of what it is you're trying to do. This, for example, is a schematic for an H-bridge controller. And what I've done is I've kind of contemplated what I needed to have in the circuit. I actually built the model on a breadboard to verify that all the parts work and they work the way I want them to, and that the parts that I've selected are compatible. And at this point I kind of sketch out what's on the breadboard, and now I'm ready to take it into OrCAD for schematic capture. So the rest of this video will kind of walk you through that process. The next video we'll talk about creating a PCB from the schematic. I show here a rough sketch and a picture of a prototype that I worked up. The general idea here is I had this concept for building a motor controller. I want to be able to get a schematic so that I can then make a circuit board from that schematic. We're going to start off by launching OrCAD. And again, we're in capture mode. We want to try to get a schematic, like a logical schematic, into OrCAD, and then we can work with it some more later on. So the first thing I need to do is make a project to hold all of my designs. So we do new project. I want to make sure that I have analog or mixed AD. This will allow me to simulate the board later on if I so choose. So we'll give this thing a name. We'll call it motor controller. We'll make sure that it's stored in a suitable directory and hit OK. So once the project has been created, we have an empty design, and in that design I just have a blank schematic page. We'll notice that there's a root symbol or a slash symbol over this folder. This is our root schematic. This is the top level schematic, and that one schematic can have a number of pages. If I go into that first page, we can actually make it a little bit more visible. I have the default connecting things to ground. Well, we always remember to do that. And I also have the default title page, which I don't care for, so I get rid of that. The first thing I usually do is place a proper title page or title block, and to do that I'll use the place tool, the title block tool, and I'll make sure that I have this Briggs library. If we don't, for instance, I can remove it. I'll have the default title blocks for OrCAD, and I don't care for those. Many companies are going to have their own custom title blocks, and so this is a pretty typical step. We're going to add that customized library. On my computer, they're stored in the C drive in a directory called OrCAD, in a directory called Capture Libs, and the one that I have that has all the parts that I've been working with for all of my projects is called Briggs. And I see there is the ship CSE library. You guys can get this same Briggs library by checking out my projects folder from SVN. That'll be a different video. So I have the default or the new Shippensburg title block, and we'll basically click through here so I can go to the title for the project, which is motor controller. And this is really the page title, and so this is the H-bridge. This is page 1. The engineer is my name, first initial, last name. I only have one sheet. Put today's date in, and we can put the revision code, which in this case is 0.0. This is our very first version. Try to get that as close to the edge as possible. The next thing we need to do is actually start placing the parts. Now, we're not trying to build the PCB directly yet. At this point, I'm just going to use some generic parts. So, for instance, we're going to come in here, and I'm going to place the MOSFETs first. And the MOSFETs, although I could go to do a part search and see if I can find an existing specific exact match for the MOSFETs that we're using, or I can just use generics. And for now, I'm just going to go ahead and use generic parts. And I know I need 3 P-type MOSFETs and 3 N-type MOSFETs. So we can drop the 3 onto our page, and then we can come in here and place 3 N-type MOSFETs. One other strategy I often do, since I know I'm going to be repeating these, is I'll just place the one pair and make it the way I want that one pair, and I can use copy and paste to fix it. If I pay attention to the pin names, this pin is the drain, and in most schematics you'd expect to see the source going up toward power. That's kind of where I want to have the power. So I need to flip this, and to flip it we're going to right click on the part, go to mirror vertically. This part has the source, which is proper, so we should see source to drain, or drain to drain configurations here. So that looks good. They're a little far apart. I'll bring them together. If these are MOSFETs, I'm typically going to have pull-ups and pull-downs on these devices. So I'm going to go back and go to PSpice component, and we're going to place a resistor. The pull up here for the P-type and a pull down here for the N-type. I want to be able to have these guys kind of going vertically, and that's not really a mirroring, that's a rotation. And what I can do is go to click on a part, go to edit, and go to rotate. And anytime you see this letter or any kind of keyboard combination under a menu, that's the keyboard shortcut. So the keyboard shortcut for rotate is actually R. So I can click on a part and just hit R, and that will spin the part. So at this point we can kind of come in here. We can delete things we don't want, get rid of those, don't need them. And because this is going to be a pull-up, I know I need to connect the gate to that resistor. And we're going to connect these guys to each other. And now I know I can go ahead and copy and paste this structure 3 times. And so there's my first, second, and third pair of MOSFETs. The next thing I know is I need to have voltage on this board. So I'm going to use the place power, which also has a shortcut of F. So I can use the toolbars over here as well. And I really prefer to use the VCC bar. That's just my personal preference. And I know that I'm going to want these motors to be running at 12 volt. And so I'm going to click on the name here. We're going to change the value to 12V. And at this point I can connect all the things that need to be connected to 12 volts. Now remember, schematics are very logical connections, so the way I'm connecting them here has very little to do. I mean, we're really after the connectivity between the points, not the actual physical paths that will be connected later on. So there's the power side of this H-bridge. The bottom side of this H-bridge is going to be connected to ground. That's going to be down here as a G. And there's pretty much only one universal symbol for ground, and that's it. So I'm going to go ahead and connect these guys. Again, I'm just using the W key to be able to rapidly draw these lines. To get out of an insert mode, I can hit escape, like that. So there's the connectivity for the MOSFET H-bridge. And if you don't really know what an H-bridge is, don't sweat that out. So the next thing I need to do is place the motor parts, and I need a connector because this is going to eventually be on a circuit board. And so the connector that's going to connect up these parts I can get by going to place, part, or just use the P key. And I already have the connector library, and that's probably where I'm going to go look for it. But if I didn't already have that, what we can do is use the search for part tool. It doesn't show up so well on this screen. It's kind of a small capture window. But what I can do is click on the pin. Oops. Sorry. I can click on the little triangle here and tear off this screen to get it to be a floating window, and now I can resize it. I can try. It's still a pretty big window. Well, looks like that's about the best size I can make it. So if I don't know what library a part is in, I can use the search tool, expand the search for part, and if I just type in a name, like say con for connector, and I do a search, it's going to come back with nothing. It's going to say, hey, there's no parts that match connector. That's because this is looking for an exact match. I can, however, use wildcards. So if I use a star for a wildcard, it'll match anything that begins with the word con. And now down here I see that I have a number of different types of connectors I can choose from. In fact, we're really looking for something that has a 3 in it. So we can, for instance, look at a con assembly plug. Or we could look for a receptacle, or we could choose a PCB connection. And that's probably just the simplest I need at this point. So hit escape, I only need one of these. And I want it to face the other direction, and so I'll mirror it this time horizontally. So I have 1, 2, 3. And one thing we can do is we can connect our connector 1 there, and I can put my connector 1 here, and 2 there, and my connector 3 there. Again, in a real circuit board you can't just have wires laying on top of wires, but this is a logical circuit, and so it's perfectly fine for what we're doing. One thing we can do with each of these wires is if I hover over them, I see they have the automatically assigned name. I can rename each of these nets to have a more descriptive name. So for instance, this could be motor A. The property editor in OrCAD is really quite nice. You can actually click on different parts at the same time and then edit all 3 at once. The problem is I don't know now which net was which net. So that's kind of a challenge. Another way to name these things is to use the net alias tool. And what that allows you to do is say this is motor A, and we can put it there. And this is motor B, and we can put it there. And this is motor C, and we can put it there. So now if I hover over this, I see that's motor C, that's motor B, and that's motor A. So those are the 3 nets that we've connected to our design here. The next thing I need to do is part of my design depends on measuring the voltage that's generated on the motor on the part that's not being driven. And so to do that, I need to get what's called a virtual neutral. And that consists of 3 resistors, each one connected to one of these lines. So again, I can come back here to PSpice component. I can place my 3 resistors. Again, I want to get them rotated down so that they're vertical. And what we're going to do is put our 3 resistors here and connect each one up to the motor coil. and then each three of these gets connected to each other. Now, again, this is something that's just part of the H-bridge construction, and so why we do it is really depending on being in the fundamental properties of the H-bridge itself. And if you're not following how the H-bridge works, that's not the point of this video. We're just using the H-bridge as an example of a circuit that we might want to create. I'm actually interested in what the voltage is on these 3 points for my H-bridge, and so what I might do is put those onto another connector. So I'll hit P to place a part, and in this case I'll probably want another, in this case, a 4 connector, because I'm going to have the voltages coming from each of the 3 motors, and then the 4th being this virtual ground. So again, I can search through here and find let's see, there's a connector assembly PCB. So really, maybe what we want to do is give it more of a search. So I didn't find that. But I now have the connector library, and honestly, the hardest part with finding parts in OrCAD is figuring out which of the many libraries that OrCAD provides has the part that you need. And so we can also have that library highlighted, connector, and there's all of our connectors, and here's a PCB connector. And so at this point now, I can put him on the board, and I can mirror him horizontally again so that he's kind of looks like he's facing out. And this connector probably is going to have a connection from here to there, and from here to there, and from here to there, and then one last one that goes down to the virtual neutral. The last step I really need here is power and ground. So that's going to be one more connector. So in this case, I'm going to look for 2. And I will mirror him horizontally as well. Now, the temptation might be to draw a wire all the way down to there, but that's really going to just make things really confusing. And so what we can do here is remember that as far as OrCAD's concerned, the connectivity comes from the nets themselves, not their drawing on the screen. So by having this net here called 12V and this net here called 12V, it knows that these are the same connections. And when we go to make a PCB, these 2 nets will be connected. This is ground or 0, so everything that says 0 is going to be connected to ground. It will inherit that required connectedness. There is one last connector I need to have, and that is the connections for the gates, and that's going to consist of 2 more connections. And so I'm going to copy and paste these 2 connectors, and now they're facing kind of the opposite direction. So click on these and make them horizontal. And this is going to be the connection for gate A. This is going to be the connection for gate B, high. Now, every once in a while, OrCAD gets it into its head that it's going to try to connect things for you. And sometimes we just don't want that to be. And part of what's going on is this wire would actually cut across the actual node junction right there. So I actually have to bring it down. Or bring it all the way up. And so now it's starting to get really confusing. Right? Now we have wires jumping all over wires. I mean, that just doesn't appeal to clarity. So instead, I think we're at a point where maybe what we should do is use connectors. And so over here, I can do place port. And so I can place 3 ports, and we'll call this A high, B high, C high. And now I can just place these 3 parts. And just like having everything on the same net makes these things connected, these ports allow me to show connections between devices without actually just drawing the wires. And we're going to do something exactly the same here for the low side. And change their names. So this becomes A low, this becomes B low, this becomes C low, and in fact I don't feel like rekeying all of these things, so I can just delete the one empty connector, copy and paste, and then change these names. So this becomes A low, B low, and C low. So now I have a connector for, say, the microcontroller to have its 3 low voltage lines come in, and then we have the MOSFETs and our connections to go to the motor and connections to power and ground. And that becomes our kind of first shot at creating a schematic from, or capturing a schematic into OrCAD. Thank you.